Hello guys, I am Krishna. Good evening guys. Today we are going to see a very much interesting topic. I am going to review a research paper on a subject called System on Chip SOC. Now I think you guys can view the slide. Wait a minute. Yeah, it's a paper called Energy Efficient Heuristic Application Mapping for Two-Dimensional Mesh-Based Network on Chip. It's based on the many topologies are there, like a 2D mesh, torus, 3D mesh, and all is coming. Future scope is called 3D mesh. Is based on the network on chip NOC. Which plays a vital role in mapping the networks in a system on the chip. I think heuristic application is a non-conventional optimization application algorithm used in that. It is the author is Pradeep Kumar Sharma, Santosh Vyas, Pinaki Mitra, who have done a very good job on this paper. I am presenting Krishna Anand from VIT Chennai, MTech VLSI Design. Now we can jump into the topic. The major agenda, I am splitting into a different topics in the paper because the paper is a little bit complicated to explain in a whole single video. So I am just dividing the topics into these sections. The major section is data and discussion and proposed scheme methodology. These three are the major section of this paper. The introduction is based on the paper what they have given to them, because the introduction means the purpose of research as well as the summary of the research. What does the paper is going to tell us? What we can receive, the what information we can receive from this paper. Is this paper is good enough to read throughout the paper? The data and the efficient are much more purposeful in our life in VLSI journey. Then a summary of that paper, a summary of that research. This is going to be in the introduction. Then we are going to see a review of the literature, because in every research paper there will be a L number of references, but they have gone through every reference in that paper. Literally 20 to 20, I think 26 reference papers were there in this paper. It's a really good paper, very very interesting. Trust me guys, you should enjoy this. Problems and hypothesis. What are the problems faced because of this? What are the problems must be overcome through that? These are the two sectors in which we are going to see the problems and hypothesis. The methodology means the basic methodology, because we are very much new to this topic, right? So they are helping us to build a base on that, which means a foundation of that topic. What is CTG, what is TG, topology graph, like that. As literally 5 to 6 definitions are there, which will create some kind of base to approach the algorithm in which they have proposed to that. They have proposed a very very unique algorithm. I am really surprised that in every aspect, because the proposed scheme I am telling now, the proposed scheme is map G to M. It's very simple as well as somewhat complicated. It's like a irony, I know that, but literally that's the truth behind us. There are many algorithms, because from the review of literature I will explain some of the algorithms which is proposed by different authors, different researchers. In this paper, the researcher have done a very good job to optimize the time as well as the power energy concept, energy efficiently doing the jobs, but constraint the bandwidth of the graph, in which the NOC plays a major role between the efficiency of energy as well as time. Energy means what? Power into time. The power taken by the by the device in which the time going on is called majorly called as energy. The energy plays a very vital role in this paper. And the data in the discussion is probably we are going to discuss about the data called MPEG-4. As already know what is MPEG-4, just we are going to discuss about that kind of in SRAM DRAM, how we are going to map into the router in that router in which the switches are there, how the switches are going to switch between them to optimize this energy so that, this energy can be efficiently made into it so NOC means a network on chip, so that how the routing plays a major role, how the placement of that topography is going to be, like that we are going to see. And at last, conclusion is this hypothesis is correct. Hypothesis means what we are facing the problem is the problem is sorted out. At last, we are going to decide. At last, we have gone through every set of the paper, research paper. At last, what we have come to know, what we have acknowledged from the paper, that is the hypothesis is correct or not, and then the future scope of the paper. Every paper has the extension of a to another researcher, so that they can research something from that paper which can be a reference to them, like that. In this paper there are many literature behind that, like that this paper may also be a future literature to some other researchers. So what are the future scope to extend this paper, like that? Okay, now we can move to the introduction. Guys, literally, I think this video will be somewhat lengthy. I'm assuring that don't be so panic about that kind of things. Literally chill out, because it will be so interesting. Trust me, guys. Now let's jump to the topic. Introduction. As I told that there will be two topics: purpose of the research and the summary of this research. What is the purpose of this research? As a title shows, that it's a mapping and applications in a 2D mesh based NOC architecture. What is NOC? What is NOC? We want to know the what is the difference between SOC and NOC. SOC is totally is called a system on the chip. In the system on the chip, where we MPNOC, which is a microprocessor system on the chip, like that many are there. But NOC minimize the architecture of the interconnected between these switches, routers, like that everything. It's a bit, like, because in the SOC, plays a major role bus plays a major role, so that the every signals going through CPU, GPU, like memory elements, like that, every signals will be delayed because of the bus. We are using AXI bus, or before, if it is a ARM processor, it will we will use ARM, API bus, etc., like that. In this it is very delayed because of a single bus transferring every signals to the every blocks. In CPU itself, there will be a memory element, as well as the main CPU or the processor. It's a cache. Everything will be uploaded there. So GPU, CPU, memory elements, input output port, for every block, there will be a single bus going through, acting as a master and slave. But in NOC, it is not like that. It's like a mesh. There are different topologies. We will explain later. It will be configured. The signals will be traveled very quickly, so that the energy efficient as well as the time efficient will play a very critical role in NOC. That is the major difference between SOC and NOC. In this paper, they are telling they are going to minimize the communication energy, because in NOC, there are two energies. Okay, what the device consumed by the device. If you are placing a SRAM into that, if you are placing a DRAM into that, the SRAM DRAM is a structured CMOS which consumes some energy from that. Okay, from supply voltage will be given, so that the energy power dissipation, that are all different topic, you know, that the capacitor parasitic capacitance plays a vital role in consuming the power like that. The communication energy is totally different from that, because every switching of the element, every switching of the transistors make an communication energy. In this paper we are presenting, they are presenting that the heuristic mapping algorithm. There are different mapping algorithm. They are going to use a heuristic mapping algorithm under the permissible bandwidth constraint, as I told before itself. These are the purpose of the research. What is the summary of the research? What the summary overall, what they are telling us to do? Exactly what I told. There are different types of mapping algorithm, right? Exact algorithm, pseudo, heterotic. Where what are the defects of exact and pseudo heterotic? They are going. I am trying to explain to you. Sorry, guys. Well, exact algorithms provide a most optimized solution. They involve in the computation time, because exactly what the optimistic solution of that processing is going to have an exact algorithm. But in pseudo heuristic algorithm are something different. They will converge nearly to the optimal solution, which means exact solution, but they are not exact, but they require very high execution time. Like that, exact algorithm also require high execution time. But heuristic techniques are not like that, dude. Heuristic technique is it will be non-optimized computation time, due to the it will search like a linear task and mapping combination, non-optimized, but the energy consumption is very less, as well as the time taken to come near the optimized solution is very less, because it is not an exact solution. In this paper they are telling us that in heuristic technique we are going to apply a clear cut exact solution, but it is not an exact solution. You should understand that. Okay, this is the keyword in the mapping algorithm, what they are using in the title. Then we can go to the literature, review of literature. I have divided the review of literature in two different perspectives. Pseudo aesthetic application, because they are using an pseudo aesthetic application techniques also there. So we are going to see some of the interesting papers in literature review. What is stimulated annealing? What is stimulated annealing? Which means they are generating some kind of signals into that mesh on the chip. So that this paper is discussed design and diagnostic of electronic circuits, IEEE workshop 2008. It was done by Zlu Zia, and I think name something I'm not clearly able to pronounce. Sorry. Then they are denoted the genetic algorithm as well as particle swarm optimization. These three are discussed. These three are taken from these three papers. So the heuristic application mapping techniques, because there are so many reference papers, I can't cover every one of them. So I am just dividing these kind of things. These techniques are pollution based greedy approaches that converges the near optimal solution and require a typically higher execution time, very typically higher execution time, but lower than the non-convex optimization solution. Example, BB and ILB. ILB is an integrated linear program which gives an optimal non-convex optimal solutions. It is very much used. We are in this algorithm is overall compared to the ILP. ILP plays a major role in that integer linear programming. Next, I have divided. I don't know. So I have divided the constructive heuristic application mapping. What the in a constructive in heuristic application mapping, many of the authors have constructed a new variety of their own work in application mapping. NMAP, MOCA. MOCA means mesh-based on-chip interconnection architecture. Then template based heuristic application mapping, champ C-champ, which means their name search engine proposed C-champ. Then castnet is a highly prioritized tag. It will be placed on a priority rise. I think I can't explain these five very clearly, but I have done a small table in which you can see what they are going to tell us. In the platform constraint, design mode, runtime, communication energy, and topology type. Topology type is everything is mesh. Platform constraint, what they are constraining, nmap, castnet, and cchamp are bandwidth only. But Mocha and template is bandwidth and latency also is constraint. Design mode is everything is offline. Offline runtime nmap is very high, but the communication energy is very low. This is nmap is literally close to that paper, but I will tell at the end of the video why nmap is very much close to that paper. Low runtime is low in Mocha, template base also low. Castnet is medium, and CChamp is medium. Castnet is also, I told no, Castnet is a it comes under a nearly optimal solution because the runtime is also medium, as well as the communication energy is also medium. In this paper we are going to discuss about the communication energy, total communication energy, which is TCE. TCE plays a vital role because energy efficient, the title itself tells that energy efficient heuristic application mapping on a 2D based NOC. Sorry guys, a little bit cold. Now we are jumping into the main problem of this. What are the issues they are facing? Requires typically high CPU time due to the linear search. I don't know. There are different exact algorithm, as well as pseudo heuristic algorithm. But heuristic algorithm is not an exact optimization, exact solution, but it is an near to the exact solution with some kind of optimization. It requires a high CPU time due to the linear search corresponding to the mapping combination. Consumes relatively highly communication energy. This high communication energy must be pulled down to the low communication energy, so that this algorithm plays a vital role, which we saw at the summary in the table. nmap plays a vital role in this, but the high CPU time, because of this only I told that in nmap plays a vital role. Nmap is actually near to the what is they are going to stay, what they are going to say, but I will say it later. Next slides are hypothesis. What are hypothesis? They are telling that their proposed algorithm called mapG2M addresses all their issues, all the problems which are faced below what they told. First issue, task selection. Task selection, they are prioritizing the task so that the CPU time will be minimized, right? Second issue, tile selection, in which SRAM, in which I am telling clearly, please note it, in which SRAM the NOC should be placed where, so that the adjacent tiles can be made more efficient, so that the energy can be consumed less. Third issue, reallocating. If this issue is not comfortable with that, if this tile and this task selection is not comfortable, is not optimized, so they are reallocating in a course to get an optimized solution to ensure that they consume very much less energy, but maybe sometimes it may be higher, but maximum of times when we compare to the another algorithm, this map to G2M plays a vital role in energy efficient, but not in bandwidth. Okay, clearly they have told in the introduction itself, so we are not going to consume that. Low CPU time under bandwidth constraint. We should note it down. Okay, then we are moving to methodology. Methodology, as I told in the introduction part itself, methodology is a base foundation what they are going to tell into that. Communication trace graph, CTG, communication trace graph. It's a weighted and directed. We have studied many weighted and unweighted graph, right? It's like a weighted. It's have a weightage. It's undirected communication trace graph. C, where the CG is equal to C comma E, where U comma V is moles V respects a task. This V represents a task or a core of NOC, and edge EK. Every node as a every edge. Two node connected to these nodes, these cores have a edge. That is E. G is equal to V comma E, represents the path between two adjacent tasks U comma V. Every core has their own task to do. SRAM has own task to do. MemDoc is have own task to do. Like that, everything has their own task to do. These tasks communicate with each other with respect to their communication path. This is trying to say the communication trace graph. What is topology graph? Topology means everyone know there are different types of topology. In this, what topology we are trying to represent a tile of a NOC. NOC have if a 2D image 4 into 4 means there will be 4 into 4 16 tiles will be there. These 16 tiles, how they are going to connect the local router. This is what is the shortest communication path from one tile to the another. Is represented by the topology graph. Mapping algorithm, how they are mapping how they are mapping from a function to a G to M. Find a function in which each vertex U come approximately V maps to the operation, where V represent a task. One task, how is they are mapping to the function. What is the routing function? Routing function is exactly similar to the mapping algorithm. It routes from a shortest communication path between two tiles. It's a routing function. Then tile symmetric candidate. When a set of size 2D mesh where 4 into 4, 4 into 4 can be divided and we can be split into four slides. I think it can be split into four partition. Okay, 25%, 25%, 25%, 25%. Let's see like that. If it is cutted into another four, then it will be 8 partitions, right? In 8 partitions, one upper left or one upper right, it can be told as tile symmetric candidate. One tile is symmetric to the another tile. It is known as tile symmetric candidate. Then tile selection of current task is responsible to find out an partial tile with respect to the currently mapped adjacent task depicted by a dotted line. If we are going to directly see the figure, I can explain much more efficiently because in figure what you are saying in A, it's an MPEG for benchmark. MPEG for benchmark means this kind of course will be there. This going to be mapped to a one NOC. In that NOC, there will be an attached to the routing from one core to another, in which is the shortest part between to communicate to each other, so that it consumes less energy. This is going what you are going to see on the figure C. What we are directly seeing. Why SRAM takes a place on that? Because SRAM is the highest sampling rate to the upsum of 910. So SRAM is given as the highest priority. Highest priority means the time taken to reach at that time, or the energy taken to reach at that time is high, means it becomes the highest priority to have an op distance. The hopping distance between these three are very much high. This four is very much high communication energy using a normal XY minimal routing algorithm. Then what they are going to propose, the proposed scheme, the problems, what problems they are going to task about that. To undergo these kind of issues, we are going to see two types. One is mapping, another one is routing. These two are very much important in this paper to understand clearly. What is mapping? Clearly, CTG we know, TG we know. Okay, one-to-one transformation from CTG to TG, CTG combination trace graph as well as topology graph, to minimize the total consumption subject so that the communication energy can be minimized simultaneously. Is a mapping. What is routing? The problem determines a dead-free routing function. Dead-free routing, deadlock-free routing, deadlock-free routing. It is very important, because if there is a just assume that there is a four core in a NOC. One core is transmitting a packet to the another core. Each core has a buffer. If the packet is filled, then the rotation of the communication between these four cores will be stopped at one point. That is called deadlock. It will not be stopped. It will act like a loop. The same request will be accepting to the another core. That task will be completed. That another same task will be routing on. That is called deadlock. We cannot remove from that lock. This is log called deadlock. Deadlock routing. In this deadlock free routing function is very much important to minimal require the bandwidth of the NOC architecture. Then we are going to see important core part of the paper, algorithm. What is map G to M algorithm? The graph consists of V comma E and a 2D mesh. Okay, what mesh can be also N into M, N into N. In a 2D mesh, M and TCE best is what we want, right? TCE, total communication energy, should be at the peak, so that we can claim that energy efficient. First of all, there will be two phases. Third phase is also that, but is not necessary. Two phases are there. First phase is initialization. Second phase is iteration. First, we want to initialize what are the adjacent core, what are the post core, what are the list of arrays that are imposing into that. This should be sorted out there first. That is called initialization. What is iteration? The initial task will be mapped to an TSE, and then the rest of the task will map to the corresponding VH onto the mesh of onto the total energy, so that the minimized is by the routing and mapping. This is furtherly explained by third step: task selection, tile selection, update, and mapping. These are the four major operation in this map G2M. Then we should calculate TCE. The energy calculation can be calculated by the formula. Then it should be iterated continuously. Then third phase is reallocation. Reallocation find out all the neighbor core should be not filled out. Okay, if it is not filled out, then the energy will be wasted out in the NOC. Then should be in the descending order, so that the energy consumption value should be on the better basis. Then we should return TC best. Like that, I can explain in this. What I told was this TSE. If we split 4 into 4 as a 4 8, there will be 8 partition. These 8 partition will be symmetric to that. This is figure 4 represents that. I can explain the algorithm easily with respect to this figure. Mapping steps of CTG. Okay, communication trace graph. First, we are going to map 5, because 5 as the highest transition graph between 10. 5 to 10 is 910, right? So 5 is mapped on the left side. There are two adjacent slides. There are two adjacent cores to 5, right? One is on the right. One is on the right of 5. One is on the bottom of the 5, below of the 5, right? In which in these two we can map whatever else we want. 10. Second, we are mapping to 10. Then we are mapping to highest priority. 7. Then we are mapping to highest priority. What is the highest priority after 10? 4, right? 4 is the highest priority. In like this, if we decide to every node what we are seeing at the MPEG 4, benchmark. If you are going to trace the and spectral as the 2D mesh, we can represent like this. There are three more adjacent nodes in which they can be placed. These are NOC. This is represented in this table because V5 as a highest priority, 5 as the highest priority, second highest priority is 2. The priority table is mentioned in that. It's very simple. You can easily understand through that. What is the what are the data they are given to recommend that map G2M is very much energy efficient, and this map G2M is implemented in C language, so that the energy efficient can be much more dropped down, right? There are six figures, but we don't want to consider the six figures. At least one figure we want to be in depth on that. MPEG 4. MPEG 4 I can explain easily because everything I want to explain this itself, I think half an hour above, I think so. I will explain as quick as possible. And what are the data? There are 12 nodes in MPEG 4. There are 12 nodes, 13 edges. In VOPD, 16 nodes and 20 edges. We can see in this figure that one 12 nodes is in MPEG 4, and VOPD has literally 16 nodes. But the edges, the interconnections between them is in MPEG 4 is 16, but in MPEG 4 is 13, but VOPD is 20. We can easily say that these are the nodes and edges. Okay, then what they have shown that as they have told in the summary itself, map to GEM consumes total communication energy is very low like nmap. In first I told no, nmap is somewhat similar to map G2M because of this only, but map G2M has a somewhat better quality than nmap because map G2M have a lower CPU time execution than nmap, because nmap has a higher CPU time execution, but it consumes a lower TCE, total communication energy. Then we have this and all some kind of benchmarks they have given by running out through the everything. What they are comparing, ILP and map G2M are very much close to each other, like they are similar. They are totally similar for every benchmarks what they are running on that MP3 encoder or MPEG 4, VOPD, NWD, everything. These are the data what they are given in the paper, and in this figure the comparison of TCE is in it's like a histogram, so that we can easily represent like that. So they are normally what we are discussed only they have given. Then it's a graph. It's literally very much important because it represents the CPU time. Nmap has very high CPU time than any other. You can see itself. Just consider the VOPD, MP4, NWD. This itself enough to in VOPD. Nmap consumes 112 milliseconds for a cycle. Uh, but in map G2M that is only 11. Sorry for the inconvenience of the presentation. Map to G2M should be on the right of ILP. Sorry for that. Map G2M has a very low CPU time because of the task selection in the mapping of the core to the body of the every part of the NOC, so that the communication shortest distance routing is applied, so that the CPU time is coming very much low than of the ILP. ILP has very high CPU time, but the accuracy is very high. Map G2M is also coming under that accuracy only, but not exactly same. They have optimized the heuristic application mapping in such a way that the optimization is coming exactly near to the exact application mapping algorithm, right? we have seen exact, pseudo, heuristic and heuristic. We are given into the heuristic algorithm, but we have come nearly, the solution is near to the exact algorithm mapping, application mapping. Then conclusion. We are at the last part. We are at the conclusion. I have divided this conclusion into two parts. Is the hypothesis is correct or not? Then it has future or not? Simple, as simple as possible. I have come to the comparative result of TC of several multimedia benchmarks and also some random generated custom CTGs found that map G2M performed better than others recent models. Installation is very much close to the optimal result contained by the ILP solver. ILP solver literally takes so much of time to solve that solution, but it gives an exact solution because it runs in an exact application mapping algorithm. But in this map G2M, the CPU time is very much lower, but it optimally, literally, it comes near to the exact solution where ILP is giving to that. Thus, I think this is very much useful and this is very much correct. I have seen the paper. Literally, I was so astonished. Because of that only, I am just explaining to you guys. Task selection can be done using two different types: closest criteria and degree of distance criteria. Okay. In a complex communication topology graph, there are different type of topology graph. In something much more complex than a 2D mesh, the no neighbor course is approximately 20 to 30 percentage when compared to the another, because the relocation process are done so that the energy is furtherly reduced by 3 percentage. It can be seen through these experimental results. Then future scope. What are the future scope? How can we expand this map G2M to another extent level? We have done 2D mesh. 2D mesh means XY only, X-axis and Y-axis. 3D mesh means Z-axis also comes under that. But it may comes into different transmitters because each course as a routers and switches topology, everything will be done. But in 3D mesh, the perspective of seeing the 2D and 3D is totally different, because XY plane and YZ plane and ZY plane comes under the diagonal lines, so that 3D mesh should be divided into further more category than 2D mesh. So the complexity increases. When the complexity increases, the algorithm should be extended up to compromise that transmission of increasing complexity, right? To if a complexity increases, the algorithm of optimization also should increase, so that they connected to have an absolute CPU time as well as an absolute CPU time to coincide with the total communication energy, because in that also the communication energy plays a major role than the device energy, because the device energy is going to be same on 2D as well as 3D, but the communication, the interlink between these two, 3D has more interlink between each core. The short communication path, what is the short communication path, how we are going to route, how we are going to map these cores to that, is literally we want to research furthermore. If you guys are very much interested to do this kind of research in NOC, you must refer this paper. It will be very much useful to you guys. The authors are some of the authors are currently working in application mapping on 3D based NOC and optimizing the energy packet transmission latency also, the time as well as energy. If a time and energy is literally going to be scope, because energy is equal to PET, so energy is directly proportional to time. If energy is decreases, the time as latency is also going to be, the delay is also going to be decreased from the one transmission packet, transmitted packet to the received packet, right? because the shorter path from the one core to the another core must be reduced in a 3D, because a 3D have more number of mapping than 2D. So, if you guys are very much interested in that, then please refer this paper. This will be very much helpful to you guys.